Welcome to our exploration of antimicrobial drugs, the powerful agents that help us combat infections caused by bacteria, viruses, fungi, and parasites. These medications have revolutionized medicine, saving countless lives and improving health outcomes worldwide. In this video, we'll delve into what antimicrobials are, how they work, and why they're so essential in modern healthcare. We'll also look at the different types of antimicrobial drugs and their unique roles in fighting disease. Let's begin by understanding the basics of these life-saving medicines. Antimicrobial drugs are substances designed to kill or inhibit the growth of microorganisms. These include bacteria, viruses, fungi, and parasites. The term antimicrobial encompasses a wide range of medications, each targeting specific types of pathogens. By interfering with the life processes of these organisms, antimicrobials help our bodies overcome infections and prevent their spread. Understanding the definition is crucial as it sets the stage for exploring the different categories and mechanisms of action. Discovery of antimicrobial drugs marked a turning point in medical history. Penicillin, the first widely used antibiotic, was discovered by Alexander Fleming in 1928. This breakthrough led to the development of many other antimicrobials, drastically reducing mortality from infectious diseases. Over the decades, scientists have continued to innovate, creating new drugs to address emerging threats. The history of antimicrobials is a testament to human ingenuity and the ongoing battle against disease. Antimicrobial drugs can be classified into several categories based on the type of microorganism they target. The main groups include antibiotics for bacteria, antivirals for viruses, antifungals for fungi, and antiparasitics for parasites. Each category has its own set of drugs, mechanisms, and uses. Understanding these types helps healthcare professionals choose the right medication for each infection, ensuring effective treatment and minimizing side effects. Antibiotics are perhaps the most well-known antimicrobial drugs. They work by targeting specific features of bacterial cells, such as their cell walls or protein synthesis machinery. By disrupting these processes, antibiotics kill bacteria or stop them from multiplying. However, antibiotics are ineffective against viruses, fungi, or parasites, making it important to use them only when appropriate. The effectiveness of antibiotics has made them a cornerstone of modern medicine. Antiviral drugs are designed to combat viral infections. Unlike bacteria, viruses use our own cells to replicate, making them harder to target. Antivirals work by interfering with the virus's ability to enter cells, replicate its genetic material, or assemble new virus particles. These drugs are crucial for treating diseases like influenza, HIV, and hepatitis. The development of antivirals has greatly improved outcomes for patients with viral infection. Viral infections can range from mild skin conditions to life-threatening diseases. Antifungal drugs target unique features of fungal cells, such as their cell membranes. By disrupting these structures, antifungals kill fungi or stop their growth. These medications are essential for treating infections like athlete's foot, ringworm, and systemic fungal diseases. The development of antifungal drugs has expanded our ability to manage a wide variety of infection. Parasites can cause serious health problems, especially in tropical regions. Antiparasitic drugs are designed to kill or inhibit the growth of parasites such as protozoa and worms. These medications work by targeting unique features of parasite biology, disrupting their life cycles and preventing disease progression. Antiparasitics are vital for treating conditions like malaria, giardiasis, and helminth infection. Antimicrobial drugs work through various mechanisms. Some disrupt cell walls, others interfere with protein synthesis, and some block genetic replication. The specific mechanism depends on the type of microorganism and the drug used. Understanding these mechanisms helps researchers develop new drugs and improve existing treatments. It also aids in predicting potential resistance and side effects. One of the biggest challenges in antimicrobial therapy is resistance. Microorganisms can evolve and develop ways to survive drug treatment. This resistance can make infection harder to treat and increase the risk of complications. Proper use of antimicrobials, including completing prescribed courses and avoiding unnecessary use, is essential to slow the spread of resistance. Researchers are constantly working to develop new drugs to overcome resistant strain. While antimicrobial drugs are generally safe, they can cause side effects. These may include allergic reactions, digestive issues, or toxicity. It's important for healthcare providers to monitor patients and adjust treatment as needed. Safety considerations also involve avoiding drug interactions and ensuring the correct dosage. By balancing effectiveness and safety, doctors can provide the best possible care. Antimicrobial drugs should always be used as prescribed by a healthcare professional. Misuse, such as taking the wrong drug or stopping treatment early, can lead to resistance and treatment failure. Following medical advice ensures that the infection is properly treated and reduces the risk of complications. Responsible use of antimicrobials is a shared responsibility between patients and providers. Antimicrobial drugs have had a profound impact on global health. They have reduced mortality from infectious diseases, improved quality of life, and enabled medical procedures that would otherwise be too risky. Their widespread use has transformed healthcare systems and contributed to longer life expectancy. However, global challenges such as resistance and access to medications remain important issues. Surgical procedures often rely on antimicrobial drugs to prevent and treat infections. Prophylactic antibiotics are given before surgery to reduce the risk of postoperative infections. These drugs are also used to manage complications if they arise. The role of antimicrobials in surgery highlights their importance in enabling safe and effective medical interventions. Beyond hospitals, antimicrobial drugs play a vital role in community health. They are used to treat common infections, prevent outbreaks, and protect vulnerable populations. Public health initiatives often focus on educating people about proper use and the dangers of resistance. Community health relies on access to effective antimicrobials and responsible usage. Fight against infectious diseases continues with ongoing research and development of new antimicrobial drugs. Scientists study microorganisms, resistance patterns, and drug mechanisms to create innovative treatments. Investment in research is essential to stay ahead of evolving pathogens and ensure a healthy future. Collaboration between governments, industry, and academia drives progress in this field. Antimicrobial drugs are also used in agriculture to prevent and treat infections in animals and plants. While this helps maintain food safety and supply, it can contribute to resistance if not managed properly. Responsible use in agriculture involves following guidelines, monitoring outcomes, and minimizing unnecessary treatments. The intersection of human and animal health is a key focus for global health organizations. Future of antimicrobial drugs faces several challenges. Resistance continues to rise, new pathogens emerge, and access to medications remains unequal. Addressing these issues requires global cooperation, investment in research, and public education. By staying vigilant and proactive, we can ensure that antimicrobials remain effective tools in the fight against infectious diseases. Individuals play a crucial role in preserving the effectiveness of antimicrobial drugs. By following prescriptions, avoiding misuse, and practicing good hygiene, everyone can help prevent the spread of resistance. Personal responsibility extends to supporting public health initiatives and staying informed about best practices. Together, we can protect the power of antimicrobials for future generations. We've covered the basics of antimicrobial drugs, their types, mechanisms, and importance in healthcare and beyond. From antibiotics to antivirals, antifungals, and antiparasitics, these medications are essential for treating infections and protecting public health. Challenges like resistance and safety require ongoing attention and responsible use. By understanding and respecting these powerful tools, we can continue to benefit from their life-saving potential. Antimicrobial drugs have transformed medicine and saved countless lives. Their continued effectiveness depends on responsible use, ongoing research, and global cooperation. As we face new challenges, it's important to stay informed and proactive. By working together, we can ensure that these vital medicines remain available and effective for generations to come. Thank you for joining us on this journey through the world of antimicrobial.